All right, so today what we're going to do is we're going to continue our look at area. And remember, we have our four formulas for different types of areas. But what we're going to do today is we're going to look at areas of composite shapes, which means that you've put together different shapes. Now, how many formulas do we have? So these shapes are all going to be combinations of those four things and nothing else. So don't think that it's going to be some shape that you don't know. No stars or weird things. It's going to be one of those four. Okay? So what we want to do is talk through a few strategies. Okay? So first, see if you can create one big shape. For example, you might see something that looks like this. Well, this is simply a trapezium, right? But I might not know some of the measurements to be able to find the shape. But I might know enough to know that this is a rectangle with a triangle cut out of it. Okay? Actually, let me redraw this somewhat to show you, because that's just a plain trapezium. I didn't draw a very good example. Okay? There we go. Let's use that. So this one is no longer a trapezium. Why?
Because it's got a little square.
There you go. It's got that little bit in the bottom. Yes. But I could extend the sides and turn it into a rectangle, and that's simply a rectangle with a triangle cut out of one corner. Do you see it?
Yeah.
Okay? Now, you can have all different kinds of shapes with pieces cut out. What big basic shape could I turn that into? Another rectangle, right? And it's got a triangle cut out of here, and it's got a little square out of there. Okay? Now, when you're doing these, second thing you need to do is write in any missing values. They're going to give you enough values for you to be able to work these problems. But they're not going to always give them to you in exactly the way you're used to seeing them. For example, it might say that this little spot is a measure of 2 meters, for example. Okay? And then it might give you that from here to here is 5 meters. Well, if these lines meet, if they're exactly the same length, then you know that the rest of this is also 2 meters. Now, usually what they'll do to say that it's the same is they'll put that little line on it, right? So that means that these two, if they have that one little line on it, that means those two are the same. So they don't even have to put the number over here. If they just put that little line there and there, you know that this side on the other side is also 2 meters, which means that the total length of this side is 7 meters, right? So you may have to add some things together, okay? Also, they may tell you that this is 4 meters, and they may tell you that from here to here is 3 meters. Well, if this side here is 3 meters, then what do you know about this part? It's also 3 meters, right? Okay? So you see that you can assume things and gather pieces of information. Here with this little square, they might give you 3 little lines. And then somewhere else, they'll give you a little line and say that's 3 meters. Well, what does that tell you about all those other places?
They're all 3. Oh, okay, now.
Yeah, they're all going to be the same. They're all going to be 3 meters, right? Just like that. Yeah, that's right. Okay? All right? So we're going to look at several of these, and you need to see, can I make a basic shape out of them? Write in any missing values. Okay? Combining when necessary. So in other words, if they give me 2 different lengths, but 2 different values, but I need to turn it into a length, I'll need to combine those, add them together. Okay, and again, we'll look at plenty of examples, and then you'll do some on your own. This is not hard. Don't make it hard. It's only difficult if you make it difficult. All right, then Okay? What you're going to do is just find the values and subtract or add the parts. Go ahead and write that down and let me kind of explain let me show you what I mean. So in this one, I would find the area of the entire rectangle. Yes? But in reality, I didn't have a rectangle. I added this triangle is cut out of it. So then I would find the area of that triangle and subtract it out. And this square up here was cut out as well. So I'd find the area of that square and subtract it out. Does that make sense? Now, if I had a shape that looks like this, I could cut that into a rectangle and a square. And then find the two areas, and since they both exist, right, they're not cut out, I would simply add them together at the end. Or, alternately, if I knew the measurements, I could turn that whole thing into a big space, right, a big square, and then subtract out this area. If I knew the measurements, which I'd have to, or else I wouldn't be able to find the areas of the others. So you see what I'm saying? Usually it's easier to find the big area and then subtract out the pieces. But what if I have something like this? That's a rectangle with a square attached, right? So then I would just find the area of the rectangle, find the area of the square, and then what? It's stuck on there, isn't it? So that's add. It's added to it. Okay? All right? So, and finally, do not forget your units. Make sure that you put these in, that you have, these are square units because it's area, right? So meters squared, centimeters squared, etc. Because area is always measured in square units. That's good? Yep. Now, do not try to turn them into shapes that you don't have formulas for. Okay? Now, if I were you, once I created that one big shape, I would probably write the formulas that you need. You don't have to, and I'm not going to be looking for it when I mark these, but if you've written down the formula, but then you've made a small mistake, say, for example, you added two numbers and got the wrong number, or you've multiplied wrong or something, I will still give you the credit because you knew what you were supposed to be doing. You just made a small error. If you don't write down the formula and show you're working and you make a mistake, I'm going to count the entire thing wrong because I don't know what you did. There's nothing I can see to give you any credit at all, right? Okay? Does that make sense? Oops. So looking at this first shape, sorry, I forgot to turn on my pencil. Hold on. Okay. Don't look at the answer. No. All right, here we go. Here's our shape. So if you notice, you have a large shape that measures 8 meters by 9 meters. So what kind of shape is that?
That is a
rectangle.
A thing. A square. A square is 8.
It can't be a square or else the sides would be the same, right? It's a rectangle, right? So this big shape is a rectangle. Yeah? It's slightly long. It looks square, but it's not. Then you have this shape cut out of it. What is that shape? Another rectangle. So we have one rectangle, a big rectangle, minus a smaller rectangle. Do you agree?
Yeah.
And what is the formula for area of a rectangle? Length times height or length times width, whichever you prefer.
Equals L times, what is L?
Yeah?
Oh,
Length. So, length of this bigger rectangle is 9 meters times, what's its width? 8.
I've got it.
8 what? Meters. Which will give you what?
72 meters. Meters squared.
Meters squared. There you go. 72 meters squared. Okay? Now, guys, calm down. Now, then we have to take this smaller rectangle. What's its length? Length is 6 meters. Answer the question you're being asked. What's its width?
3 meters.
3 meters.
18 meters squared.
18 meters
Meters
squared.
squared.
There you go.
Centimeters squared.
And remember, this one is cut out of that one. So what am I going to do? Add or subtract?
Subtract 72 to
It's
18.
54.
I don't know.
Meters squared.
54 meters squared. Thank you very much for that. Okay? So keep it simple.
Makes sense.
Write down everything.
Wait. I'm not ready yet.
Okay? To make sure that you have every bit of it written down. So let's look at the next shape. So if you look at this next shape, they've drawn in some dotted lines to demonstrate to you that although you have this odd shape, if you just connect that corner and connect those two lines, you end up with a big what?
Square.
No, rectangle. It's a rectangle. Yeah. All right. So you end up with a big rectangle. So what I need to do is I need to find the area of this big rectangle, right? And then if you look, this piece is cut out. What shape is that?
Triangle.
Triangle. And this piece is cut out. What shape is that?
That's a rectangle.
Another rectangle. Okay? So if I label these B, C, and D, we're going to find the area of B and then subtract the area of C and the area of D. Do you agree? Okay? So first we need to find the area of the big rectangle. So I know that if we look down here, this says that whole long length is 12 centimeters. Yes? So that's going to be the length. And it says that this whole side is 8 centimeters. So that's going to be the width. So area equals length times width for that rectangle. So it's 12 centimeters. Do not forget your units. Times 8 centimeters, which is going to give me what?
Oh wait, I was just gonna ask, are we allowed to memorize the width times length?
Doesn't matter.
Doesn't matter?
No. We talked about that earlier. It doesn't matter the order when you're multiplying, yeah? Okay? What's 8 times 12, guys?
96?
96. Centimeters squared. Good. Okay? So we have 96 centimeters squared as our big area. But we have some stuff cut out of that. So let's first look at the triangle. Remember, for triangle, the area equals base times height divided by what? 2. Or 1/2 times base times height, which is the same thing. This looks better for most people. So if we look at this, it doesn't really matter which one we call the base and which one we call the height. No. So which one do you want to call what?
The 6 centimeters base.
Okay, doesn't matter because this triangle makes a perfect corner. It doesn't really matter. One edge is going to be the height. Now, if you had a triangle that looked like this, then it's very important that you measure the height out there, right? But since this triangle is making one corner of a rectangle, we know that one of them is the length, is the height, and one of them is the base, and it doesn't matter what you call which. Okay, so if you want to call the 6 centimeters times the 4 centimeters. And then we're going to divide that by 2. So what's 4 centimeters times 6 centimeters? 24 centimeters, what? Squared divided by 2 is 12 centimeters squared. And again, that's cut out of our rectangle, so we need to be subtracting that one. Now let's do the bottom one, and that is a rectangle. And it's 2 centimeters by 8 centimeters. 2 times 8 is going to give me 16 centimeters, what? Squared. What if some of these units over here were different?
It'll be harder.
Well, then before I could add or subtract them, I would have to make them match. Yeah? Okay, so we're just going to subtract those 3 things. You've got your calculators. What's 96 minus 12 minus 16 going to make? 68 centimeters squared. Oh, what'd you get?
Well, I got 56 centimeters.
56?
Probably not, yeah. Because I did 8.
No, it should be an 8.
Wait, can I just read out what I did?
We
So look for those basic shapes. Sometimes it's just 2 shapes put together. Well, yes, you could. If you wanted to make it into one big shape and then cut that out, that you could do that one. Yeah, if you wanted to. There's usually more than one way. All right. So what you're going to do is you're going to work on these. These are on page 246. It's exercise 11E. I'm going to turn this off, so no, you can't use mine. You need to use your own because I want you to check your answers as you go. What would you have learned if you do them all wrong?
Nothing.
Well, worse than nothing. You would have learned how to do it wrong, which is worse than knowing nothing. All right? Okay, there we go. I'm going to stop the recording.